Customer Segmentation Using K-Means by Stuti, Chase, and Cassidy, myself. So customer segmentation is really important for businesses to understand their target customers and their target audiences, and it can help businesses curate personalized advertisements to different segments of customers. So in this project, we use a K-means clustering algorithm, which takes in unlabeled customer data and assigns each data point to different clusters. And then we chose an e-commerce database that lists purchases made by 4,000 customers over the span of a year. And then based on the analysis in this data set, we can develop a model that would allow us to anticipate purchases made by a new customer. So this is like just some of our data set, and the features of it are the invoice number, the stock code, which is basically like a product code, and then the description of the product, the quantity ordered, the invoice date, the unit price, the customer ID, and then the country that the customer is ordering from. And then we began our analysis. We did exploratory data analysis, and there were 25% of entries that weren't assigned to any customer, like they didn't have any customer ID assigned to them. So it made it impossible to impute values for the users. So we deleted those from our data frame. And then we plotted a choropleth map to see just like the demographic distribution of the data. And we determined the number of products purchased in every transaction. And then also from the results, we saw that there were some orders with a prefix C in their invoice numbers, which means they were canceled. And we found that 16% of the total transactions were canceled orders. And then after some more basic data analysis on the other features, we introduced a new feature called basket price, which allowed which groups every purchase and indicates the total price of an order. So to understand the division of the purchases, we made a pie chart of breakdown of order amounts. And then we extract information from the description feature and create a list of keywords and filter out the ones that appear less than 13 times or that carry no information. And then we can use the keywords to create groups of products. And then we used one hot encoding on the keywords to create different price ranges.
All right, so now after we analyze the data, we're going to group the products into different classes. So the metric that we used for calculating distances was the Euclidean distance. And then to define the number of clusters that best fits our data, we use the silhouette score. Basically, the silhouette score rates how good the clustering method is per like each number of clusters. So it ranges from -1 to 1, and 1 means that the clusters are well apart from each other. -1 means that the clusters are not assigned properly, and 0 means that the distance between the clusters is insignificant. So below you can see what the formula for the silhouette score is. Basically, it's B minus A over the max of AB, where A equals the average distance between each point within a cluster, and B is the average distance between all of the clusters. So as you can see, after looking at the clusters, we ended up choosing 5 clusters because after 5 clusters, basically the number of elements in each cluster became very small. So 5 seemed like the best one to proceed with. So then we move on to create clusters for the customers. So basically what we're going to do is take each of the clusters for the products and assign them the clusters for customers. So then what we do is we collected information related to a single order and put it in a single entry. Then we grouped together different entries corresponding to the same user, and it gave us information such as like the average amount spent, the maximum spent, and the minimum spent, which can be used later on for targeted advertising. So during our analysis, we also found that there are 40% of customers who have made just one purchase. Then again, based on silhouette scores, we decided that the optimal number of clusters would be 11. So Now moving on to our results. So our goal was to classify a customer after their first visit. So we test three different types of classifiers. So we have support vector machines classifier, we have logistic regression, and K nearest neighbors. So basically we see that SVC ended up having 79.8% accuracy. Logistic regression had 90.58% accuracy, and the K nearest neighbors ended up having 82% accuracy. So when we took a look at the graphs, we ended up seeing that, like, for SVC and for logistic regression, they converge towards the end, which is good because it means that our model is not overfitting or underfitting. And we ended up seeing that logistic regression performed the best on an unseen data set with an accuracy of 85%. So, in conclusion, the project was based on a database providing details on purchases made on an e-commerce platform over a period of 1 year. So, given the information, we divided the customers into different categories based on their purchasing history. So then we developed a model to predict what type of purchase each customer would make. So to achieve the goal, we ended up dividing the different types of products into 5 different clusters, and then we divided the types of items that a customer would buy into 11 different clusters, and we saw that our model could classify 85% of the customers correctly. And in order to improve the model, we could consider things like seasons, festivals, or holidays, and more. Thank you.